Hi all, I'm about to give due to. I can't talk much because the contest is about to start right now in 1 minute 25 seconds. I'll try to talk something about them because you people will get bored very easily, right? Otherwise, like we can see the score distribution. Maybe like we have A, B, C1, C2. Okay, they are nice problems. You guys can try to solve them well. D is also a nice problem probably. And then we have E more difficult than F1 and F2. Fine. How to be quick, how to try to do quicker. Like I want to improve my speed, I want to improve my rating, I want to do better than you people. I'm just joking, we all should do better than what we are doing, right? Mhm. I'll try to explain as I go a bit. Okay, I'll try to explain. I'll try to see the steps are simple. Write the problem neatly, see it well, see it clear, try to solve the problem. Write the necessary conditions as long as they are sufficient. At each moment, pause and see if it is enough. Teja is playing the hit rhythm game OSU. The game can be described by a binary string and a position feature K where the following will happen in order. You will choose some positions in S to protect. For each I in increasing order, Teja can set SI to 0 if if all the following are true. SI is 1, SI is not protected. The previous K minus 1 elements do not contain 1. So when can someone change? You have 1 followed by 1 0 1. Okay, if you have 1 and k minus 1 zeros, that is not protected, right? So you have to protect all such ones. You have to protect all such ones. Why? Even if you leave one of that one, it has zeros, no one restricts it, you can remove it. So you have to protect all such ones. That's it. One, here you need not protect anything. Okay, one does not occur. Okay, so for this, you have to protect that. For first one, you have to protect. Okay, so we see number of zeros before that. If you just have when the last one has occurred, k minus 1 zeros, we should all such ones must be removed, must be protected, and protecting them is enough. Also, one should be protected. So it is like, let L represent the last one, which I will keep it to be minus n. For int I equals to 0, I less than n, I plus plus. If s of I equals to 1, not even s of I, char c, c in c, if c int answer equals to 0, if c equals to 1, if I minus L, number of greater than or equals to k means k minus 1 plus 1, right? Then answer plus plus, you will protect this I. L equals to I. Can k be 0? It's not being. We output this answer. It's perfectly correct, right? I'm assuming the initial one is far away. Initial one is far away so that the initial ones are covered. And my logic is that haven't I not registered to this contest? Fuck it. Let me solve B. An arbitrary array of b integers of length m is considered awesome if for all I, if I is odd, then bi less than bi plus 1 wholes. If I is even, bi greater than bi plus 1 wholes. So it's like zigzag, zigzag, right? It's like zigzag, zigzag, zigzag. Okay, it's just this zigzag. You're given an array of positive integers a of length, and you may do either of the following operations any number of times in any order, either of them any number of times in any order. Select an integer I. Select an integer I and do ai equals to max of that and replace ai with prefix max up to I. That is, okay, we can just replace it with prefix max. Select an integer I and decrease it by 1. Determine the minimum number of operations you need to enough times. Okay, this is free. Minimum number of times you need to do operation to make a awesome. So not that you do not need to minimize the number of times of operation 1. So we have to get a lower bound here, right? Because it's a minimization problem. We have to see how many times we can reduce these things. Okay, we want b2 should be higher, right? So if it is already perfect, it's already perfect. And then what do we decrease? We probably decrease odd values. We probably apply this to even values, right? Applying this to odd seems meaningless, right? Anyway, it should go down. That's the constraint, right? Make increasing it doesn't seem, if you apply it and it becomes bigger, that doesn't seem to help anyone, right? If you are reducing max, that also doesn't seem to help anyone, right? So what should you do? If b1 is greater than b2, b2 cannot be increased, right? Just see case wise. If b1 greater than or equals to b2, b2 cannot be increased. Why? Okay, b2 can be increased. You can you can make b2 equals to b1 and reduce b1 by 1. Okay, so we have cases, I guess. If b1 equals to b2 minus 1, if b1 equals to b2, b1 greater than b2, if b1 less than b2, you don't do anything. If b1 less than b2, you need not do anything. Leave b1 alone. b2 is there, you cannot increase it further. You have to go and solve the problem further with having the power to increase b2. In this case, what you should do? In this case, you have to apply at least two operations. So the best operations you can apply is b2 equals to b1, b1 minus minus. These are the best things you can do here. Two operations. Anyway, you have to do two operations. Increase b2 while you can. Okay. In this case, what you have to do? You cannot increase this. Just do b1 minus minus and proceed further. So now we are at b2. So now we are at b2. You cannot change b2. You cannot increase b2 further. Why? b2 has been increased to its max. You cannot increase b2 further. So now you have b3, b4 up to so on. So now what you should do? You cannot increase b2. Okay? And you have this value. This should be smaller. If this is greater than b2, you must reduce it to less than b2. Okay, b3 will become But before doing that, you can increase this thing and then you can reduce that, right? You must reduce this thing. Maybe let's come from behind for this case because it's being a bit problematic, right? Let's come from lost. Bn, okay, because values are only decreasing. Taking prefix max in the front is better, right? Because values would decrease because of these things, values are decreasing. So maybe if it can help something, try to help in the beginning and then reduce, because you must reduce before reducing, help everything, right? So let's come from behind. If bn is greater than, okay, we have two cases, n is odd and n is even. Okay, let's say n is odd. Am I missing something here? We have b3, right? We have b3. b3 is less than b2, let's say. Then we are probably good. With, okay, let's say these are the cases. B2 greater than B3 means it seems fine. You need not worry about that. You have to worry about these two things now. And you can always make B4 2 maximum B3 or B2. Okay, you can make any B4 to B2 in one OP. Even here you must reduce B3, right? B3 minus minus, and then you have to solve the problem further again. You have a value that, let's keep a value that maximum that has ever existed in a prefix, okay? Maximum that has ever existed in a prefix. This is what you can make any value to, right? Initially, it is b1. B1 is the value that has ever existed in a prefix, right? Okay, so at each step, what can you do? You can either increase the even value. I mean, I should not be thinking this much of time. It's not being easy to me. But I should believe in golden rules. I have to look at it well. I have to look at it again. Maybe there is some observation that simplifies things. Okay. Okay, if I come from behind, if n is odd, bn less than bn minus 1, we are good. If bn equals to bn minus 1, you can reduce bn minus 1 or increase bn. Sorry, you can reduce bn or increase bn minus 1. So if they are equal, increasing this, if it is increasing, it's one operation, right? And that's better. If bn minus 1 equals to is greater than is less than bn, now you have to reduce it at least twice, right? If it's increasing, increase it and then reduce this thing. So now this seems fine from behind. So now you're at bn minus 1 and bn minus 2. Okay, so now the problem is solved. Now this doesn't come into picture at all. You have done your best, you're here, you have done your best. Now the end is even. What you have to do when end is even? You have to make, you cannot make this one bigger. You have to make this one smaller, right? So instead of making, if this one can become big, okay, again, if this one reduces, that may help both of these two things, right? If this one reduces, that can help both of these two. If this one reduces, that can help both. This should be bigger. Okay. This can probably cannot be made bigger, right? Or it can be made bigger sometimes. So, so if bn minus 1 is greater than bn minus 2, we are good. Okay. If bn minus 1 equals to bn minus 2, then if bn minus 1 can be increased, increase it. That takes one operation, right? No, no, no. You won't increase it. Decrease bn minus 2 because this is better, right? If both of them are equal, decreasing bn minus 2 is better. Why? That helps the previous things, right? Rather than increasing it. If bn minus 1 equals to bn minus is less than bn minus 2, now you have to think. Bn minus 2 should become at least less than bn minus 1, right? It should become that small. Should I look at two things? Okay, guess one answer. All the odd things, we have to make them, all the even things can be made into prefixes, prefix maximums, and all the odd things should be reduced. This can be one thing, right? 1 minute. If B2 becomes greater than B3, then B4 can be saved in one OP. With respect to B3, you can just increase it. I don't know why I'm not able to do this B. I shouldn't be like this, right? Now what you can do? If you can increase it, you can increase it. I think you can increase it and then maybe reduce this. You can increase it. You can increase it to some prefix, reduce it below that. Now, anything previous can be saved in O of 1. I'm trying to code before making solution clear, but the solution I'm thinking is find prefix maximums, come from behind. If the last value is odd, you try to reduce it. Okay? Or increase the previous one. Whichever is better. Okay, if this is already smaller, just ignore that. Because this is never going to reduce, right? If it is bigger, then increase this and reduce that. Okay, I think we have that greedy. If equal, increasing this is again benefitable, right? So I'll come from behind. I don't know why that seems better. So if I reminded 2 equals to 0, this is odd, right? Even. I greater than 0. Because when we are here, we try to fix things for this thing. Okay, now we have to make this one smaller, right? If b of I equals to b of I minus 1, if, if b of I is already smaller, we don't do anything. If b of I is greater, if b of I is greater, what you have to do? If it increases, increasing is the first step, right? I mean, we're trying to make greedily the previous one bigger. Okay, we're trying to make greedily the previous one first bigger. Now what you have to do? It cannot become much bigger. You have to make reduce it, right? So answer plus equals to maximum of int of 0 comma. You have to make it less than b of I minus 1. B of I should become B of I minus 1 minus 1. Okay. You have to make B of I to B of I minus 1 minus 1. You have to make it smaller than that. Here, what you can do. If, again, same thing. Right. If you can increase that, increasing that is better. But if you cannot increase that, we have to decrease that. So I'll just keep it like that then. Okay, now we are at even. We will again try to do something greedy. If b of I is less than or is less than b of I minus 1. Okay, now this is smaller. You have to increase it. Else, if b of I equals to b of I minus 1. Let me think about the equal case once again here. Okay, what is the equal case? Both of them are equal. If this can be increased, that's more, that's greedy, right? But if that cannot be increased, you reduce it. That seems fine because even thing should be increased. What about here? Here, reducing this is better, right? But wait a minute. Here, b of I is smaller, right? Increasing b of I is better. You can do in two operations by reducing it once. You can make bi minus 1 equals to. Let me just try to find lower bounds, okay? Fuck. B of odd must be reduced by pref of odd greater than 1 must be reduced by pref of I minus 1 minus 1. It should be less than or equals to this thing, right? For sure. Why? The previous thing can only be increased to that value. So that should be less than or equals to that value. So first let's just do this. First let's just do this. All of these things must be reduced to that value, right? First let's just do this. Because all of them must be done. So now you are here. So now you are here. All the odd things are satisfied well. So now this pair, this relation can be saved using one OP. This relation can be saved using one OP. Okay, this seems fine. See, lower bounds are the way, guys. You can do random try, but then lower bounds are the way. Ref of I minus 1 minus 1, right? Now look at failing relations between I comma I minus 1. Okay, if there is a failing relation, one of them is odd, right? That means this even is smaller than or equals to. You can just make it using pref, you can save that relation in O of 1. You can save that relation in O of 1. You can save both of them. You can save both of them. Like if you are here, you can save both of them by changing it to pref of I. Why? This itself is less than or equals to pref of I minus 1. By changing it to pref of I, you can save both of them. And then you go further. So now it's clear. Now, if you look at any even, you can save things of this even by doing I to pref of I. Why? You have to save, you have to do one operation among these things, right? But maybe the both of them are equal. Instead of increasing this and this, you can reduce this ones. Maybe that is there now. Okay, now you have few equal. Okay, when they are equal, you can you can do one operation to save these two, or you can do one operation to save these two. That's the way now. Okay, so now you can do one operation to save anything. So now do greedily. Okay, you have some unsaved things, right? You can do one operation to save these two. You can do one operation to save these two. That's the way. So try to come greedily. When you are here, you try to, instead of this, you try to do this to save them. Now you can do greedy. B of 1 should be handled separately. How to handle B of 1? If B of 1 is small, you are good. If B of 1 is greater than B of 1, then B of 1 equals to B of 0, and you do B of 0 minus minus. If they both are equal, okay, you can do greedy by coming from this side. I think you cannot do greedy by coming from this side, but you can do greedy coming from this side because prefixes are saved in that way, right? But I'm complicating this somehow. Just look at prefix max. All the odd positions less than or equals to this must be reduced. This doesn't seem easy. Fuck it, should I go to C? But then I should not be doing like this. Contest will fuck up if I keep doing like this. Light. Okay, whatever the prefix maxes you're wanting to do, you can do them in the beginning, right? In an optimal solution, whatever the prefix maxes you are wanting to do, you can do them in the beginning. Okay. So because of that, I can change everything to. I was thinking, can I come from this side or from this side, right? I can come from any side because the increases that I want to do, I can do them in the beginning, and then everything has reduced to prefer 5 minus 1. So that works. So first, what I will do, I will make all of them to b of I minus pref of I minus 1 minus 1. Okay, all of them will be reduced to this because this must be done, right? I was worrying. Now we have these things. Now, in one operation, you can save these two things. If you are increasing in one operation, you can save these two things too. See, reducing this will only be beneficial when all of them are equal. Okay. Only when these two are equal, reducing this may benefit. If these two are equal, okay, if b of I minus 1 is greater than or equals to b of I, then answer plus plus b of I equals to ref of I. But if that was less already, now if these two are equal, b of I plus 1 minus minus answer plus plus. This would have been better here. If I greater than less than b of I plus 1. See, we are first trying to save the previous one. Otherwise, we are trying to say these two things. If that was saved, this also has been saved. The fuck am I doing? Why is it so complex? It's becoming complex because I'm trying to think of b of 0 now. Otherwise, it's perfect. What is this, guys? Only b of 0 is trying to cause some problem to me here. Otherwise, if this has been applied, this will never happen. And now we are trying to do it again a bit greedily. B of I is less than B of I plus 1. You must make it pref of I, right? Because you have to anyway reduce that by twice. But what about B of 0? If B of I minus 1, this never happens. This also never happens. Okay, if this happens, you can reduce that. Instead of doing all these things, would this work? Okay, you should also make these things. How can you do here in one operations? You can't increase in one this in one operation. You can't reduce this in one operation. Fuck! You should only reduce operations of type 2, right? What have I done? What have I done? You can't throw the problem away, guys. You can't throw the problem away. You have to keep your mind here. Fuck can I do now? Okay, from now let me go quicker. Can I make it again? This seems a difficult version. Not even a difficult version, that's just stupid. Okay, let me solve the problem here. So now let's see how easily I can solve the problem. Okay, I'll try to go quicker on the next ones, but let's see how I can go solve the problem now. Minimize only operation of type 2. So increase all even things to max already. Now decrease odd things accordingly. Is that it? Is that it? Fuck this thing. Fuck this thing. Fuck this thing. So now what we should do? I'll just, for implementation purpose, I'll just make b of 0 equals to 1e, uh, 10, b of n plus 1 equals to 1e 10. You have to make it minimum of the minus 1, right? Submit it. Fuck it. What have I done? Let me go quicker, guys. I'm still in the game. If I can solve more problems, right? If you find yourself with two arrays of positive integers a and b, both of length, you find yourself with two arrays of positive integers a and b, both of length, and you will perform the following operation any number of times. Select an integer I and increase ai by 1. The cost of this is bi. You find yourself with two arrays of positive integers a and b of both of length, and you will perform the following operation any number of times, possibly none. Select any integer and increase ai by the cost of that is bi. So cost for each index is different. You can increase it by 1. Here all bi equals to 1, it seems. Determine the minimum total cost to make it such that there exist two integers I comma j. So if there should exist two integers, you should only increase those two things, right? You should only change those two things, right, that are changing. What is this? Let me read the problem well. Let me read the problem well. You find yourself with two arrays of positive integers. You will perform the following operation any number of times. Determine the minimum total cost to make it so that there exist two integers whose GCD greater than 1. Means both of them are divisible by some number, right? AI is less than or equals to this thing. So it's brute force, right? It's brute force, right? His name is Brian. So it's, let's say for G, GCDB G, it means minimum cost to make two things multiples of G. That's the question for some G. Okay, this is the question. You can always make them even. So here answer equals to either 2 or 1 or 0. Okay. So which part is difficult here? 2 is always possible. 1 is also always possible if there is one even number, 1 is possible. If all of them are odd, See, this BI doesn't add much. What BI says is when AI goes to some G, multiple G plus something, AI says its weight is that difference times BI. Okay. So for 0 to be possible, okay, for G, number of things in G or its multiples should be 2, greater than or equals to 2. For 1 to be possible, for G, number of things in G or its multiples plus 1, which is in kg or in q times g or q times g plus 1, this should be greater than or equals to 1, and this should be greater than or equals to 1. 2 is always possible. Okay, these are the case, these are the things. Okay, so if you just have frequencies over all n, we are done, we are good. Define n int frequency of n, okay, equals to 0. Let's say we have frequencies of all multiples is what we need. The fuck is this now? Okay, because it's being like this, find all divisors. Find all divisors of AI. Okay, I'm doing it in reverse way because we cannot go over all of them. I mean, max is not bounded, right? So I'm trying to and find counts of G multiples based on this. Okay. Similarly, do find frequencies of Q times G plus 1 using divisors of f I minus 1. Okay, so we have divisors. So you have divisors, right? So let's just have this frequency and frequency 1. Okay, this will just say number of G such that Q times G greater than or number of indices like this. This will say number of indices like this. Frequency 1 will say number of indices like that. Okay. pos dot pushback of g, because that's a possible value, right? For the potential g finally. Okay, and frequency of g plus plus for int g dev of x minus 1, pos dot pushback of g, frequency of g plus plus. This is frequency 1. Okay, now what I do for int g pos, okay, int answer equals to 2. If frequency of g greater than or equals to 2, means there are two indices that are multiples of it, right? Answer equals to, answer equals to 0. Else if frequency of g greater than or equals to 1 and frequency of g greater than or equals, frequency 1 of g greater than or equals to 1, means there is a multiple and there is one thing which can be saved in one operation. Answer equals to minimum of answer comma 1. So this is done. This is good. We have to, there is some error somewhere. His name is Brian. Mm. I thought this might happen. I think this should be x plus 1. Okay, why? After adding 1, it becomes divisor of that, right? Answer is 2 for this, it seems. Okay, we are pushing. Okay, I have to make the frequency 0. So this one is simple. Now we have to think quite a bit on C2. His name is Brian. This was instantly solved, like this was not fuck. This is not any difficult problem. Just like asking you to find divisors. If you can find divisors, you can solve the problem. His name is Brian. Brute force problem. Bad problem. So let's think of C2 if C2 is any good. Okay, now for C2, BI can be anything and still we have our answer. Okay. The problem is same again. But what changes? Stating the problem is very important. Minimum cost. So we need G. Okay. We need G such that AI reminder G times BI plus BI reminder, sorry, AJ reminder G times BJ is minimized. This is what we should be doing now. See, I haven't stated the problem this well here because we have two always, like minimum cost two is always possible. But here, this is what you can say. If you keep G equals to 2, 1, 1, that's why it was previously that. You guys should write this one very clearly, right? Like it's a problem. So this is what you have to do. You have to make, I mean, the opposite reminder. What is opposite reminder? The other reminder. Okay. So now, is it brute force? Is there something nice? His name is Brian. You can always have b of I plus b of j. Answer less than or equals to this. Using g equals to 2. Okay. Okay. Answer is less than or equals to this again. What does that mean? Means if there is a smaller answer, so this is possible. Okay, this is possible. And now, if there is a smaller answer, if there is a smaller answer, means either a of I reminder g equals to 0 or b of a of j reminder g equals to 0. Right? Why? Otherwise, both of them are non-zero. You can make them one, right? This gives out that g divides a of I. And now what we want? Now what we want? Now we want for each g. Now we want for each g. There is a for so valid g or having some multiple. Okay, if there are two multiples, we are done. In the same way as the previous problem, if there are two multiples, the answer is 0. Keep the frequency 1 aside. If there are two multiples, the answer is 0. So now there is only one multiple or 0 multiples. For each valid z, now there is only one multiple. Okay, so there is one multiple. If g has two multiples, answer is 0. If g has one multiple, if g has no multiple, we don't even care about that. Why you don't care about that? Because for that, both of them will be 1 1. Instead of that, you can take 2, and then you're good, you're better. Right? So g has one multiple. These are the g's we have to care about. For this g, what is the other thing you will try to minimize? You will minimize G minus A of j remainder j times B of j. You should minimize this thing. Okay. So you have some potent G. Okay. What do I mean by potent G? One multiple has already occurred. Let's call them potent G's. So now, what does this mean? What does this mean? It's nothing but if you add, so you have potent G's, right? I'm trying to find minimum value of this thing for each of these potent G's. Okay. So no G will fall if you consider G and G's multiples. Okay. You have some potential G's. Okay. And you want to see the closest G's multiple here. Maybe some root and brute force. Okay. Some root and brute force. For that, you have to be very clear. What is this means? Adding something, it is nothing but q times g greater than or equals to a of j, smallest q times g. Right? Why? You're trying to make it one of g's multiple, right? You're trying to make it one of g's multiple. It's all about stating the problem well. See this. For a of j, it's like we have some potential g multiples. It's like the minimum q times g is what you want here. Okay. Minimum q times g is what you want here. So, smallest q times g greater than or equals to this you want here. So, if both q greater than root n and g greater than root n, that's definitely possible. Right, this definitely happens. So, most of the cases, we have to worry about q less than or equals to root n or g less than or equals to root n. These are the only cases you have to worry about. Okay. It seems these are the only cases worry about. If you cover all these cases, okay, of q comma g, then what is left is for g greater than root n. So let me just think of these things. Let me write it better. G less than or equals to root n. Okay. You will go over all them and find smallest q and you have your answer. Is g greater than root n? There are only q multiples. Okay, if you if there are only root n multiples less than n, if you keep going over them one after the other, so answer will be q is less than or equals to root n plus 1, let's say. Why? If it is great less than or equals to root n, why? If it is greater than root n, both of them multiply. Let this be seal of root n. Okay, both of them multiplied will exceed root n, right? Let's just say this one because this itself is satisfying, right? Root n plus 1 times root n itself is satisfied, so q among these things one will be the answer. So what do we do for that? We fix q here and we try to find minimum g such a way that that is potent. Here if you fix q, you just want minimum g that is greater than some value. Okay, how do you get that quick? Binary search seems too much. You can do binary search obviously, maybe lower bound, but then n root n log n, would that work? I doubt that. Can I get it quicker? The problem is done. N root n solution is here, but then can I get it quicker? Why did they make C to itself n root n? That seems weird. Maybe it's not n root n. It has some potential G's. You have random values. Other than this root n log n, is there anything better? I don't think there is anything better. So let me just quote this one. Okay. What are potent G's? Something that divides ones. These are potent G's. Pause or potent G's. Let me make it set. So let me write some solution. If it goes TLE, then we can see. We want min of q times g minus a of I greater than or equals to 0. It's actually greater than 0. Okay, why? There is one thing that is already equals to 0, right? For some of the things. So we want this greater than 0, so that the other thing we take that, but for this we take this. I want root n. Define root n be 700, 300, or 320. What about 400? 420. Haha. No, 440. 450 seems fine. Okay, if g is smaller, now we want minimum q such that q times g greater than a of I greater than or equals to q minus 1 times g. So this is a of I by g, right? So q is a of I by g plus 1. Okay. Answer equals to minimum of answer comma b of I times q times g minus a of I. So we're brute forcing that. So now we brute force q. Q equals to 1, q less than or equals to root n, let's say. I will even make it q less than or equals to root n plus 1 for safety purposes. Because what are the remaining cases? For g greater than n, this itself exceeds n, right? You have an answer within this for all g's. So for g greater than root n, we have these q's. Now we are trying to find the minimum g. Okay. So we want g greater than a of I by q. Right? It's again the same thing. Int g equals to a of I by q plus 1. Okay. So now we want auto f equals to lower bound of pos dot begin of comma pos dot end of if not f if f not equals to pos dot end of his name is Brian. There is something that is greater than this. Answer equals to g equals to star f. This is the g. How is the answer changing? Okay, I said the cost is 2, but how can 2 be possible? Right, it cannot, right? 2 cannot be possible. Bum, 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 bum. Okay, I'm doing double counting somehow. If G divides C of I, we skip here, let's say. Okay, but what about here? How to eliminate those G's? We should skip G's that divides A of I. I thought making it greater than 0 will help them skip us, but nah, it won't. What about here? Here, how can I do that? I can do that if I keep this as a set and then if I remove those divisors and then I add those divisors. But this seems very complex, right? My screen there. I don't know the time this will take. O of n log n root n log n. If both of them are positive, okay, this should be SB of SB. Why did I sort? It should be TLE. If it is TLE, maybe I'll remove this and submit it again. His name is Brown. Fuck it. A cat lives on a tree with n nodes. The cat starts on node 1 and you live on node n. You're going to leave the cat a note written in the parkour language to help it reach you. The parkour language has types of instructions. This means that the cat should move to any adjacent node to it. If there are multiple options, it will pick one of them arbitrarily. If there are no adjacent nodes to it, then it will not move. So this means the cat should move to any adjacent node to it. If there are multiple options, it will pick one of them arbitrarily. If there are no adjacent nodes to it, it will not move. Okay? There will always be an adjacent node, right? This means to destroy. Okay, you're destroying. Node U and all adjacent edges to it. The cat is currently and it will die, so this should be avoided. Do not kill the cat. Cat shock. If node U was already destroyed, then nothing will happen. There cannot be two consecutive instances of the same instructions. Having 2U to U is bad. Having 1 1 is also bad. It's a good problem. It's a good and easy problem. An answer always exists, it seems. An answer always exists. Whatever the cat chooses to do. Cat is at 1, it must go through to n. In a tree, there is a unique path, and hence cat must follow this path. Okay, we have this path from 1 to n. Cat must follow this path. So what do? We try to remove things. This is 1, let's say, this is x, let's say. We try to keep removing, smashing things on this side. Cat chooses arbitrarily. One thing can be sure. What? See, if you keep, see, there are some things onto 1, right? I think the problem is solved for me. If you keep removing things on 1, then finally cat leaves 1. Then you kill 1 too. If you proceed further, you can make cat reach n. Okay, you have to kill all of these things. You need not kill anything on n, because if all of them are killed, cat will be going to n, right? So how would you do that? See, kill a leaf on subtree 1. Kill a leaf. Keep doing that. But how do you make sure that cat is not there? If, see, if you paint everything as odd node and even node, you can know where, if a cat is in an odd node or even node, right? Because of number of ones, there will definitely be an adjacent node, as long as the size of the tree, if you keep the size of the tree greater than or equals to 1, it will definitely be an adjacent node. So if you're removing leaves, you will always have the cat a choice, so it will definitely move. So if you paint everything as odd and even, based on number of ones, you can know if your cat lies here or not. If number of ones says your cat may lie here, then what do? Do 1 and now remove the leaf. You are at n. Okay, you keep root at n. Keep destroying leaves, making sure cat is not dead. Cat will not be dead. And you're destroying leaves. You're destroying all random fucking leaves. Okay. Based on number of ones that have been done so far, the problem is done. You're destroying all leaves. Cat is safe. Means cat will come to end eventually. Once you destroyed all the leaves. Even if it has entered n and then it left, finally it will come to n because cat is not dead, right? Done. Simple and nice problem. See, these problems exist. I suffered on C2, C1, right? But then see, this problem is very nice. So number of ones. Let me just see number of ones with C1. Okay. Let's also have this height h. Height will just say even or odd for me. It's a nice problem. It got solved very easily. 3n operations, 2 operations to kill, 2 operations to move, 1 operation to kill. I think 2n operations is enough for me. The fuck? There cannot be 2 consecutive instances of second instruction. That's why 3n. Is that it? Is that it? Because there cannot be 2 consecutive instances of second instruction, even if the cat is not here. Here, you do twice, and then you kill that. Okay, before every second instruction, you do twice and kill, or you do once and kill. If the cat is here, do once and kill. If the cat is not here, do twice and kill. I don't know why this one they're told. I think this makes sense because so that cat can understand whenever a 2 comes, cat can decode it. Maybe for that reason it is that it's beautiful, guys. Even though it seems not helpful to the problem, then the cat can decode. Take 1, 1, 1, 2, take that. I don't know. It need not be like that. Even if it was 2, 1, 2, 1, 2, 1, it works, right? Fuck it anyway. We need height of 1 because the cat is initially in there, right? So we have heights. Now what do we do? See, guys, problems high like D or you need not get scared at all. Okay, problems are problems. So now we have heights. Okay, vector pair int answer. Answer dot clear of, let's say int cat is in int c height, let's say. What is cat height initially? H of 0, right? And it flips after each one you do. His name is Brian. You remove all the children and then you remove this. That's the DFS now. You remove all the children and then you remove this V. Okay. v equals to n, if v equals to p, okay, if v not equals to p, you remove all the children. You remove all the children. DFS removes all the children, and then you remove v. How do you remove v? How do you remove v? If c height of if c height equals to h of v, means cat can be here. Okay, cat can be here. You do answer dot pushback of 1 comma 0, answer dot, now cat won't be here. Else you do answer dot pushback of 1 comma 0 twice. What happens here? C height changes. Cat will be somewhere else now. So after doing these things, you have two ones. Now you can smash this node because cat is not here, right? So now you do answer dot pushback of 2 comma v. Now v can be smashed. So you smash all the childrens and then you smash v. You're good. Even if it comes to n, even if it leaves, okay, finally it will be at n. You remove everything. I think if it passes test one passes everything. I think I have implemented it well. Simple code, right? It seemed like 2n was enough, but we cannot allow adjacent things that 2n was needed. I should be doing n comma n and height of 1. Can I do e now? In 9 minutes. You're given a positive integers a of length n and a positive integer k, and you will play the following game with them. At the start of the game, you will choose an odd integer x. Then do the following at most k times. Select the subsequences a of length x. Then replace every value in the subsequences with the median of that subsequence. More formally, pick them, make them their median. Note that the answer x you choose cannot change between operations. Okay, you choose an odd integer x. So this was also a direct problem, right? Direct problem. You cannot kill this path. You have to remove these things. Kill leaves, keep one and n connected. Kill leaf, Don't kill cat. Keep n. Save n. Save n. Don't kill n. Don't kill cat. Kill leaves. Done. Keep cat connected with n and remove leaves. Make the tree shorter. It's a direct problem. You guys will get scared unnecessarily. Otherwise, it's a direct problem. Direct and good problem. Okay, we first fix the x, it seems. You first fix the x. If you fix the x, what is the answer? If x equals to 1, the sum will not change at all. It's the median. Median will make the other thing smaller too, right? Okay, you can choose any subsequence. Okay. Take the. Okay, this is being direct. Some of this is being direct, right? If you fix x, let y equals to x plus 1 by 2, take max y elements and make everything equal to this. Is that the answer? See, if x equals to 5, you take 3, you make everything equal to that. If x equals to 3, you take last two elements, which is 3 comma 2, and then you can make everything equals to 2. So it's direct. But then how do you compute this sum is the question, right? You sort it for these x. Okay, at most k times is a problem again. If it is infinite number of times, then it is done. Because it is at most k times, now you have to not choose these things, but you have to choose the things. Okay, you can choose these things itself, but then you choose the starting seal of k things. Oh, even this seems doable, right? You sort them, you have this value, you see how many y's you can take. I think this is not difficult. Brute force x. From here, try to increase them to this max value. From here, try to increase them to the max value. His name is Brian. Can I code this quick? This is an easy problem. I don't know. This is easier than A or B. But why is it not having solves? Is it difficult to implement or am I missing something? Should I read F1? A permutation B is considered a refill shuffle of a permutation A if mod A equals to mod B and there exists a case such that K is less than mod A such that are both subsequences of B. Damn. Refill shuffle. Seems a nice problem. So you take some subsequence, you move them forward. Then it is a refill shuffle. Seems nice problem, right? What is a riffle shuffle of 1 to n means? You have at max the permutation can be splitted into Riffle shuffle of sorted means implies permutation can be splitted into two increasing subsequences. No, 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 no. It means you have for some I 1, 2 up to so on I and I plus 1, I plus 2 up to so on n as subsequences in I. In A. What does that mean? I plus 1 occurs less than I plus 2. All of this happens. All of this also happens. Except for 1, for everything these things happen. Like I plus 1 before occurring I plus 2 up to so on. This thing happens for everything except I plus 2. Except for 1, for everything these things happen. Then it's a riffle shuffle. That's an easy way to see, right? Is the contest done? So you can choose, you can see for each pairs when one occurred, when two occurred, up to so on. You can see these conditions. Okay, you'll see these conditions. If any of them is already failing, that is your potential I plus one. Okay, and then what you have to do? You have your potential I plus one. If none of them are failing, any of them can be your potential I plus one. If you have a potential I plus one, I failing means you have 1 2 up to so on I in some positions, right? You have I plus 1 I plus 2 up to so on and in some positions, right? You have to fill both of them such a way that everything is filled and these things are increasing, these things are increasing. It may or may not be possible. I think this can be done somehow like this, right? Light. Maybe we have to simplify it a bit further. I'm ending the stream, okay?